Welcome back, team. Today's challenge is the Nth Fibonacci Number challenge. In this challenge, we have the Fibonacci sequence, which is this series of numbers right here. Each, the last two numbers add to make the next number, right? So 1 plus 1 is 2, 2 plus 3 is 5, so on, etc. down the line. And we want to figure out what the number is at a specific location. So right here we have, we're passing in 4. So 1, 2, 3, 4. The fourth number is 2, which returns 2, and we get it. Now, this is not the first time we've done Fibonacci. In fact, there was a time back in August when they had a similar challenge where your goal was to create the array, right? So we can actually lean on that code right here. This is the code that I had for that challenge, and I will link to a video on that later on. But we had that. Now, in order to make this work, I'm not going to quite explain it here, but I'm going to flip some things around. I'm going to move the start sequence to the end because for that one, we actually had a start sequence so that we could start in the middle or start with different numbers for the Fibonacci sequence. Here, we're always starting with 0 and 1, so we're just going to default it to 0, 1. And then down here, we can absolutely do that, where we return that Fibonacci sequence, copy it, paste it down, just like this, pass in our number, and it doesn't work. Why doesn't it work? Oh, because it returns an array, right? So we need to go dot at -1. And now it succeeds. Does it work? Yes. Did I explain anything? No, I didn't explain anything because this is not a fast solution, okay? We have built a whole array of things just so that we could get the very last one, which is kind of slow. Here you'll see in a quick speed test that building that array, I mean, it's still a split, a very small part of a millisecond, but we can do a faster solution. And that's what we're going to look at right now, okay? So I'm going to comment all this out. We're going to start again really fast, but we might steal some things from here, okay? So down here, it's not going to be this. Let's return it to n just for a hot second and get started, okay? Now, if we're doing this for real, we should have an error state for negatives, okay? So they didn't give us any negatives, but I'm going to leave a comment there. That's something that you might want to add if it's professional work. We should be thinking about stuff like that. Now, if it's 0 or 1, okay? So if it's not a negative, if it's 0 or 1, well, we need those two numbers to start, right? So really, we should just return those directly. There's no reason to go any further because if it's 0, there's nothing before that to do anything. If it's 1, we're adding it to 0, which is 1, okay? So we're going to cheat a little bit here and go if n is less than equal to 1, so if it's 1 or 0, right, then we return n. So a little bit of a cheat code there. And then going down here, we are going to grab this loop, okay? I'm going to cheat a little bit. I'm going to create a loop, but I'm going to delete a bunch of stuff from here in a second. Oh, it's jumping around because my cursor doesn't want to work. There it is. Just like this. We don't need this part anymore. This can go away. In fact, we don't need this either. We're only using the loop. And because we already have 0 and 1 covered, we can start at 2, just like this, okay? Length, we no longer have length. We want that to be n, and everything else kind of just works, okay? So inside of here, we are going to store, or we're going to update some variables, which we haven't created yet. So right above that, let's go and create that. We only need 2 variables for this, okay? We need the previous number and the current number, okay? The previous number is going to be, unsurprisingly, it's going to start at 0, okay? And the current number is going to start at 1, right? Because we covered that, 0 and 1. So right there, we have that. We can semicolon this if you really want to. And now we can do stuff with that. Inside of here, we should go let next equal previous plus, if I could find it, current, just like this. And then, of course, previous is going to equal current, and current is going to equal next. So a bit of a loop there, okay? But we'll come back to that in a second. And then from here, we return current. And it works, okay? It works quite well. Now, this variable right here, this next variable, it's a little bit heavy. If you're using older JavaScript, you will have to do it this way, but we can shortcut that, okay, using some destructuring, right? So right here, we can go previous and current equals another array, right, which is current and current plus previous, right? And again, we get the exact same thing. So right here, what we've done is we have created that loop, right? We haven't really done anything. We've still captured it. Instead of capturing an array of things, which takes up space in memory and slows things down, potentially, we only store two values, two pointers. And then we just update the values inside of those pointers each time until we get our final current value. And this, if I was doing this today, this is how I would do it, unless I already had this function ready to go. If I already have the function ready to go, then I'll use it, right? Because it's not, again, it's not super slow, but if I was doing this for a high-performing application, you might want to test things. And that's where we check things out. We make sure that they work, okay? So this has been today's challenge, the nth Fibonacci number, right? We're getting that, and we did it. Pretty easy, right? Not the only solution. I'm sure that there are others. If you have a cool one or one that you want to share, hit me up in the comments. I'd love to see that. Otherwise, I will see you tomorrow.